Ladies and gentlemen, welcome to lecture number 4. In this lecture, we will discuss about bending moment diagram and shear force diagram for overhang simply supported beam. So without wasting any further time, let's start. This is the overhang beam. The UDL is given as 2 kN per meter and a point load at the tip of the overhang is given 2 kN, and we have to find the shear force diagram, bending moment diagrams, and also we have to find out the point of contraflexure, and again we have to calculate the maximum positive and maximum negative moments. First of all, what is point of contraflexure? The point of contraflexure is the point where the sign of bending moment changes. This change can be either positive to negative or negative to positive. If the sign of bending moment changes, that means the curvature at that point of the beam changes. So we will calculate the point where bending moment changes their sign, and that will be the point of contraflexure. So let's start. First of all, we have to find out the reaction forces. These reaction forces can be calculated using the equilibrium equation. So the first is the equilibrium equation. Sigma all forces in y direction is equal to 0 and moment about z axis is equal to 0. These three are the equilibrium equation. Let's say it as RA. Reaction at B, let's say this is RB. So first we are doing sigma force in y direction is equal to 0. What we'll get is RA, this is the force in positive y direction, plus RB, this is the force in the positive y direction, minus we have a point load 2 kN in downward direction, minus 2, and a UDL, this UDL in downward direction, minus 2 into the length of UDL is 4 plus 2 is equal to 6 meter. This is equal to 0. This is the first equation. And RA plus RB is equal to 14. This is the first equation. Now we have two unknown and we got only one equation. Now we'll write a moment equilibrium equation, that is sigma mz is equal to 0. We will take all the moment at point A, here A. So we are taking anti-clockwise moment as positive and clockwise moment as negative. So RB, this force into distance 4 meter is positive. We can write RB into 4, distance is 4 meter. We can write RA into distance from point A to the point where RA force is acting is 0, so this will be equal to 0, minus this point load 2 into distance from C to A is 6. Again we have to take moment of the UDL about point A. It will be equal to total load. Total load for this is 2 into 6. 2 is the UDL and 6 is the length, into distance of CG of UDL from A to C to the point A, and CG of this will be at distance 3 here, so into 6 by 2, 3, that will be equal to 0, and here we will get RB is equal to 36 minus 12 by 4, so it will be equal to 48 by 4, 12 kilonewton. We know RB 12 Newton. We put RB in equation 1. We will get RA. It will be equal to 2 kilonewton. So till now we have calculated RA is equal to 2 kilonewton and RB is equal to 12 kilonewton. Now let's find shear force at any distance x from point A. Let's take a section at x. So shear force at section x is equal to sum of all the forces left to that section. It will be equal to RA minus the UDL, that is 2 into the length, that is equal to x, and this is valid for x is equal to 0 to 4. Now if x is in between 4 to 6, then in that case the shear force will be equal to RA minus 2x plus RB, because we have RB load here. So shear force at x is equal to RA is 2 minus 2 into x for 0 to x in between 4, and 2 minus 2x plus 12 if x in between 4 to 6. We have calculated shear force. Now we will calculate moment at section x. Here we are taking sagging moment. Suppose this is a section, this moment, sagging moment as positive moment. This is the positive moment. Then it will be equal to reaction RA into x, moment is equal to force into distance, minus this moment due to the UDL, it is equal to WL square by 2, means UDL W2 into distance is x square by 2, and this is valid only when the x is in between 0 to 4. If x is more than 4 meter, in that case the moment is equal to RA into x minus 2x square by 2 plus RB into this distance x minus 4. This is if x is equal to 4 to 6. Let's calculate this value. We'll put value of RA and RB in these equations, and what we get is RA is 2x minus x square if x in between 0 to 4, and then this is 2x minus x square. RB is 12 into x minus 4 or 4 to 6. Let's again solve this, and what we'll get 2. Let's take out x common and 2x minus 1. And we have to resolve this part, so it will be equal to, so just write down this value, minus x square plus 14x minus 48, x in between 4 to 6. We have calculated all the shear force at all sections, and we have calculated the moment at all the sections. Now we will draw the shear force diagram using this relation and moment diagram using this relation. So let's draw. First we will draw the shear force diagram and then the moment diagram. For length AB, we have a shear force 2 minus 2x. This is the shear force. So we will draw that. And this value is 2 minus 2x. It will go like this. If you put x is equal to 4, then this value is 6 minus 6. This value is minus 6 here. And then again from B to C we have this value 2 minus 2x plus 12. This is positive, negative, positive. This is the shear force diagram. Then we will draw the moment diagram. The equation for this line is 2 into x into 2x minus 1, x into 2x minus 1, if x is in between 0 to 4, and equation of this is x square minus x square plus 14x minus 48. Now, what is the value, maximum value, this value and this value? Maximum positive value, maximum negative value. This is the point, this is x is equal to 1. To get the maximum moment, we have to find the maximum value of x into 2x minus 1. mx is equal to x into 2 minus x, so we will differentiate it to get the maximum value. Del mx by dmx by dx is equal to 0, hence 2 minus 2x is equal to 0, x is equal to 1. At x is equal to 1, we have maximum value. So put x is equal to 1 in this equation, we will get 1. This is the 1 kilonewton meter. And what is the value here? Put x is equal to 4 in that equation. So m moment at x is equal to 4 will be equal to 4 into 2 minus 4 minus 8 kilonewton meter. This value is minus 8 kilonewton meter. Again we have to calculate the point of contraflexure. So this is the point where bending moment changes its sign. So in this diagram, bending moment changing their sign at this point. So we have to calculate this point. We can see at this point moment is equal to 0. So moment x into 2 minus x is equal to 0. We can get x is equal to 2. So this is the point of contraflexure. This is the location of point of contraflexure. So we have drawn the shear force diagram, bending moment diagram, and we have also calculated the point of contraflexure, that is equal to at x is equal to 2. We have also calculated maximum positive and negative bending moment. Maximum positive bending moment is equal to 1 kilonewton meter and maximum negative bending moment is equal to minus 8 kilonewton meter. So here we come at the end of the lecture. I thank all of the students for their patience and the SEMEXCEL team for writing